Okay, so now we're gonna do 3.16a. So the instructions read, solve each system giving the solution set in vector notation, identify a particular solution and the solution of the homogeneous system. So the first thing I'm going to do is I'm going to rewrite it as a matrix, right? Take your time doing that. Don't mess up on that. 0, 3, and of course I'll mess up a million times. Anyways, so now look here. This, I'm going to multiply this first row by -2 to get -4, -2, 2, -2. And then I'm going to add it to the next row. 2, 1, -1, 1, 0, -3, 2, 1. And now it's in echelon form. I'm debating whether I want to make it look a little bit nicer, but it's fine at this point. As long as we have it in echelon form, we don't need it in reduced echelon form. I was debating whether or not I wanted to make it reduced echelon form, but this will do, because what we see is that z is the free variable. And we're going to write z and y are both free, and we're going to write everything in terms of z and y. So how do we do this? We're going to say this bottom equation says negative 3y plus 2z is equal to 1, which means that I'm going to get negative 3y is equal to negative 2z plus 1, and then I'm going to divide by negative 3 to get something that looks like this. Y is negative 1/3 plus 2/3 z. And then now I back plug into this equation, 2x plus y minus z, which is the top row, right? And now I'm going to write it as 2x minus 1/3 plus 2/3 of a z minus a z is equal to 1, gives me, right? These combine, 2/3 of a z minus 3/3 of a z is minus 1/3 of a z. And when I add the 1/3 over, I get 4/3. So x minus 1/3, so 2x is equal to 4/3 plus 1/3 z. And then x is equal to 2/3 plus 1/6 of a z. And now with these two, I've written the leading variables in terms of the free variables. Therefore, I can start writing my solution, x, y, z. And we want to illustrate something important in this case that they have in the question, but we'll see. So we got 2/3, and then we got negative 1/3 for the constant, and then 0 constants for the z, right? Wait, but isn't... Oh, no, y isn't free. Oh, z is the only one that's free. Sorry, guys. Yeah, z is the only one that's free, which is good, okay? Because it's not the leading variable of any row. Y is the leading variable of the second row, and that's why it's not free. And what I said at the beginning is a little wrong. Now, z is here, and then what do I get here? I'm going to have 1/6 of a z, and then for y, I got 2/3 of a z, and then 1 z here, and then we know z is contained inside R. And this is the solution set. Now, we should see that this here is going to be a particular solution. And then this is a homogeneous solution. So let's check to make sure that this here is a particular solution. So 2/3, right, is 4/3 plus y is negative 1/3, and then z is 0 should equal 1, right? And does it? Yeah, because this adds to 1. So this does equal 1, and then it works for the... Then now let's check the next equation. So 8/3 minus 1/3 minus negative 1/3 is 9/3, which thank God is 3. So this is indeed a particular solution. So that's what they were asking. Particular. And then we want to see that this is always a homogeneous solution for any z. So I'm going to pick 6 for z because that's going to make it easy, because 6 times 1/6 is just going to be 1. And then 6 times 2/3 is just going to be 4. And then 6 times 1 is just 6. So 1, 4, 6 should be a solution to the homogeneous system. So then that means that it should be that, 2x plus y minus z is equal to 0. And then 4x minus y is equal to 0. And this should be a solution to the homogeneous thing. So let's see. 2 plus 4 minus 6 equals 0 for sure. So there we go. That satisfies that. And then 4 minus 4 is also equal to 0. And we could have taken z to be anything, and it would be a solution to the homogeneous system. But this is the solution set in general, this here. And the idea is that this is a homogeneous solution. And then that's it.